In this video, we'll discuss antiderivative. So basically, the inverse direction of taking the derivative of a given function. So we know that in physics, right? In physics, if you have a particle or some object moving in a straight line, you have a object moving in a straight x-axis, right? Straight line. Given the position function, function, and taking a derivative, you get velocity, right? And taking the derivative velocity, you get acceleration. Function, right? Three functions. And so going forward, we are taking derivatives. So differentiation, derivative, derivative. But in many situations, we might be given the acceleration. We want to know the velocity. Or you know the velocity, you want to know the position function. So which means in many situations, you want to take the inverse of derivative. We call that antiderivative, right? So going from acceleration to velocity, this direction is called antiderivative. Go from here to here is also called antiderivative. Okay, so let's write down a official definition for the antiderivative. Definition. So we say that f here is an antiderivative of f on an interval I. So that's if what happens. If you take a derivative of this capital F, you get lowercase f for all x inside I, right? So if you know the derivative of capital F inside on the interval I is lowercase f, then capital F is called an antiderivative of f, right? Let's see a quick example here. Example. So we want to know what is the antiderivative of f of x equal to 3x squared. So basically the question is asking for the function whose derivative is 3x squared, right? So that's a power function. For sure, we want to use power rule. We know that if you have a power function, xa prime is what? Is a times x to a minus 1. So the antiderivative x squared should be the function involved should be x cubed, right? Because derivative taking 3 down, you get 2. So you have a 3 in front, which means we know that x cubed for sure whose derivative is 3x squared, right? You can check that by the power rule, right? Or x squared x cubed plus let's say plus 3. That's another one, right? Plus any constant actually, right? So in general, the most general antiderivative of x squared, 3x squared is f of x is x cubed plus a constant, right? This constant is a constant. Could be 1, could be 0, could be 100. That's an undetermined constant, right? So recall that this is always true. Just recall that. So this means if you are given a function, the antiderivative is not unique, right? There are many functions. There are actually infinite functions whose derivative equal to the given function, right? So unlike differentiation derivative, if you have a function, derivative is unique, but antiderivative is not unique. There are many functions, but they are related, right? Recall that when we discuss mean value theorem, we have a fact. So if you have f prime equal to g prime, two functions share the same derivative, right? Then their difference is also kind of constant, plus c, where c here is a constant. As in this whole discussion, whole section in chapter 5 also, c is always a representation of a constant, right? That's a constant, could be any numbers. So, okay, so if you have two functions, they share the same derivative, they are strongly related, one minus the other is a constant. So the most general antiderivative of a given function is one derivative plus a constant, one antiderivative plus a constant, right? So that's the most general antiderivative of a given function. Just find any antiderivative, then plus a constant. So let's write down our very important result theorem, right? The way to discuss the antiderivative. So if f here is a particular antiderivative of f on the interval I, then the most, normally we are asking for the most general antiderivative of f on I is f of x plus a constant, where c here is a constant. So to find the antiderivative of a given function, right? So all you need to do is find the one of the particular antiderivative. That would be good. So let's try to using our knowledge on differentiation derivatives to get a particular antiderivative for the list of elementary functions, right? And functions, the list of elementary functions, and also we want to get a particular antiderivative. Let's start from easy function, power function x n here, and for sure n cannot be -1 and equal to -1 is a different case, right? For n not being -1, then the antiderivative should be x to n plus 1 involved, x to n plus 1, because derivative is bring down n plus 1 and times bring down n plus n plus 1, then minus 1 in the exponent position, right? But the duality of this is n plus 1 times x to n, right? We are looking for the function x to n here. Just cancel the n plus 1. So that's the why n equal to 1, negative 1 doesn't work. If n is negative 1, n plus 1 is 0. What if n is negative 1, which is same as x to negative 1, right? Whose derivative is 1 of x? We know that that is natural log of x, right? And exponential function, the derivative doesn't change. Sine of x, whose derivative is sine? Cosine is negative sine, put a negative in front. Then cosine of x, whose derivative is cosine? We know that's sine of x. Let's put in a few more, right? This is our function. This is a particular antiderivative, right? Let's say secant square of x, whose derivative is secant square. We know that tangent of x, the derivative of tangent give you secant square, right? And two more functions, 1 over root 1 minus x squared, arc sine of x, and 1 over 1 plus x squared. And the antiderivative, one of them is arc tangent of x. So if you're looking for the most general antiderivative, all you need to do is plus a constant c. So that's very important. So make sure you include c in the answer if the problem is given in a test or a final exam, right? Okay. So let's see a quick example here. Two quick examples, right? Example. We want to find the most general antiderivative of the following function, right? Which sometimes we just call that antiderivative instead of the most general antiderivative. First function here is f of x equal to 1 over 2 x squared minus 5x plus 3. Right? Remember, when you try to take a derivative of sum or difference or multiply by number, all you need to do is take the derivative of each terms, then make a difference, right? Same thing happens here. Go backward. Still, all you need to do is take the derivative of each term, right? Then multiply it by the same number or different, make a difference or take a sum, right? So the most general antiderivative of f is, let's call that capital F of x. So that's our standard notation here. So f is representing, lowercase f representing the original function, capital F represent the antiderivative of this given function, right? So this is 1/2 the antiderivative of x squared using our table of antiderivative of elementary function. So this is 1/2 1/3 x to 3, right? Minus 5 times 1/2 x squared, then plus 3 times x. So 3 times x derivative is that. In the end, plus a constant. So this is a particular antiderivative. Then plus c give you the most general antiderivative. So all the sum rule, difference rule, constant multiple rule still works in this case. Just take the antiderivative term by term, right? So if you want to simplify, so this is 1 over 6 x cubed minus 5 over 2 x squared plus 3x plus a constant. So let's see B, one more example. Our function f of x equal to 3x to 4 minus root x over x. Remember, we don't have any quotient rule or product rule, anything like that. Only sum, difference, constant multiple works. All the others fails, right, in terms of antiderivative. So this function here is a quotient. We are taking the antiderivative. We don't have quotient rule, so we have to simplify this to a difference or sum of function or sum of elementary functions. So this function can be simplified to 3x to 3 minus x to negative 1 over 2, right? Because the first term is 3x to 4 over x. Second term is root x over x, right? We know that root x over x is x to 1/2 minus 1, which is x to negative 1/2. Now you can see that both terms are power functions, so we are ready to write down the most general antiderivative of f is capital F of x equal to 3 times 1 over 4 x to 4 minus 1 over negative 1/2 plus 1 x to negative 1/2 plus 1 plus a constant. Right? So this is 3 over 4 x to 4 minus 2 times x to 1/2 then plus a constant. So that's the most general antiderivative of such a function, right? Okay.